Hello. Let's make a video in English. A few days ago, I was watching some videos of Michio Kaku. Michio Kaku is a physicist, American physicist, and he has a TV show called Physics of the Impossible, and several videos are available here on YouTube. And I was watching several of them, and one of them talks about about parallel universes, and there was another also talking about how to about teleportation, and it's very interesting. I was thinking about these ideas, and how can we travel to parallel universe? First of all, we have to define what is a parallel universe. I was thinking about it, and my conclusion is that a parallel universe is a cross section of the four-dimensional universe. Let's suppose we live in a four-dimensional universe. As a cross section of a four-dimensional universe is a three-dimensional universe. For example, let's take an orange. An orange is a three-dimensional object. If you cut a slice of an orange, a very thin slice, you can say that that slice is a two-dimensional object if it's very thin. And the idea here is, if you take a slice from a 3D object, you get a 2D object. In the same way, if you take a slice of a four-dimensional object, you get a three-dimensional object. If the universe has four dimensions, a cross-section, a slice of this four-dimensional universe is a three-dimensional universe. In the same way, if you take an orange, you can cut as many slices as you wish. But because the orange is spherical, a different slice will be slightly different. The slices will be slightly different for each other. In the same way, if you cut a new slice from the four-dimensional universe, you get a three-dimensional universe that is slightly different from other slices. And what I was thinking is, a parallel universe is a slice, a cross-section of this four-dimensional universe, a new cross-section, a new slice. And we as three-dimensional creatures, we are living in one of these slices, one three-dimensional slice of the universe. So, I had some, some interesting ideas about it. And let's think about one-dimensional. What happens when you travel from a one-dimensional universe to a two-dimensional universe? If you have a one-dimensional universe, it's only length. You have only one dimension, only length. You can go forward or backwards. That's all you can do. And the distance between 2 points is defined by what you can travel in this one-dimensional universe. But if this one-dimensional universe is actually curved, the distance between 2 points may be shorter. That's one of the conclusions I can have. In a higher dimension, the distance between 2 points may be shorter if the universe is curved. And because it happens in the one dimension to two dimensions, the same thing may happen from 3 dimension to 4 dimensions. So if you and another idea I was having is that let's suppose a one-dimensional universe or object in a two-dimensional space, for example. Because one-dimensional object has only length, so it's a line, or it could be a curve, of course. But let's suppose it's a line. At any given point of this line, you can imagine a second line that intersects the first line. So at any given point of the first line, you can have infinite lines that intersects at any given point. So the idea here is, if each line is a universe, you have infinite universes that intersects any given point, any given place. And I'm not going to call this new universe as a parallel universe. It's not a. It could be, in more precise terms, it should be an intersecting universe. But it's very interesting because if you have such an intersecting universe, it means that it is another universe that shares one point with our universe. It's not, they are not completely different. They have one point that is exactly the same, the intersection point. If we could somehow, at this point, at this intersection point, change direction, you could move to another universe. And then, if you change direction again, you could move to a parallel universe. Parallel meaning a real parallel universe that doesn't have any intersecting points with our universe. But the idea, the word parallel universe it doesn't need to be parallel. It could be, in my case, an intersecting universe. And each one of these new universes would be just like ours, three-dimensional. If you have a line, for example, you have a one-dimensional universe. An intersecting line is also one-dimensional. If you are traveling from one line to another line. So the idea here is, it's not possible to travel directly from the three-dimension to the four-dimensional. But you can change universes. You can go to a three-dimensional universe to another three-dimensional universe. I think that's theoretically it should be possible. It's not possible to go directly from the three-dimension to the four-dimension, but you can go to a three-dimension to another three-dimensional universe, and then change again. You can move along through the four-dimensional universe, but also always changing from one three-dimensional universe to another three-dimensional universe. And each universe will have an intersecting point, will have a point in common. They will share one place that is exactly the same for both universes. Another idea that I have is, if you have an orange, if you take two slices, parallel slices of an orange, because the orange is spherical, each slice will be slightly different from the previous slides. It means that a parallel universe is almost identical to our own universe. It will be only slightly different. That's one of the conclusions that I take. Okay.